Innovation is in our DNA. This is how we expand the limits of knowledge and our technological frontiers for discovering, developing, and producing in various giant oil fields in ultra-deep water, in a complex production operation, confirming our technical capacity and global leadership, all with maximum production efficiency and lower carbon emissions. This is energy for transformation.
Welcome everybody for this OTC live event. My name is Fabrício Soares. I have been working at Petrobras for the last 16 years, mainly on FPSO project management and engineering. I'm currently the General Manager of Surface Systems Engineering for Petrobras Offshore Production Development Projects. I'll be the moderator of the session today, and I'm privileged to be here with Viviana Coelho on such a relevant topic as challenges and opportunities for Petrobras decarbonization. Viviana is Climate Change Executive Manager at Petrobras. She is a chemical engineer and also biologist with a master's degree in environmental technology from Imperial College. She also holds an MBA in Advanced Administration, a postgraduate degree in innovation, and extensive executive training in institutions such as INSEAD, IMD, Cambridge University, London Business School, and Columbia University. She currently represents Petrobras on the Executive Committee of the Oil and Gas Climate Initiative and the Climate Change Group at IPICA. Previously, she held various functions in Petrobras Downstream and Research and Development, including General Manager of the portfolios of Innovation and Gas, Energy, and Sustainable Development. Prior to Petrobras, she worked as a consultant on projects for multinationals from different segments in several countries. Before we get started, I want to remind everyone that in this format, you will be able to ask questions. So I encourage you to interact in the chat box and we will reply them in the end of the session. So welcome to this live. I hope you enjoy. Viviana, be welcome. It's with you now.
Thank you, Fabrício. It's a real pleasure to be with you here today. And thanks for everyone that has joined us on this discussion on a very current topic on the decarbonization of the oil and gas industry and the decarbonization of Petrobras in particular. So I'll get started so that we make sure that we have some time for interactions and for questions at the end. And I'll get started by saying a very brief summary on how Petrobras contributes to energy transition and to low carbon transition. So first I would like to mention that we produce low carbon oil in the Brazilian ultra deep water. So we're a very specialized company in terms of competences, and we like to call ourselves specialists in low carbon oil. And why is that? You're going to see further down that our fields are among the most decarbonized in the world, in the sense that you produce with less emissions per barrel of oil output. That really means, so when we look at the world, oil, of course, is a commodity, and with a world market and a certain demand, and this demand is given by several suppliers. And we like to say that if we were to stop production right now, emissions would increase the next day, because this oil would be replaced by another oil that will be produced with more carbon than we currently operate. So this is something we're very proud of. Oil demand is a challenge of the world. Our scenarios show that there will be a retraction in oil demand in the long run, but it's a decade movement. And we think it's very important that the oil demand of the world, all throughout the short, the medium, and the long term, is always met by the least carbon product. So the second thing that Petrobras works is on gas and thermal power generation, mostly in Brazil. And it's important to notice that Brazil has 85% renewables in its electricity matrix and 50% renewables in the energy matrix as a whole. So when you see such high levels of renewables in the electricity, we are talking about 85 is really the ambition of the world in 2050, let's say, 85% renewables in electricity. So we were talking about so much electricity that comes from renewable sources and therefore has seasonality aspects and intermittency aspects. It's very important to have dispatchable energy. You need to have dispatchable energy that you can at any time supply to make sure that you always have electricity available. So right now, in this very moment, we have a very low use of thermal power energy in Brazil, and we are having almost all of our electricity supply by renewables. But just 6 months ago, it was the opposite, and we really needed gas to compensate for a hydric crisis that had our electricity system in need for dispatchable energy. So this is a role that Petrobras is a company that operates in the electricity markets for over a decade, and it's a role that the company supplies for the stability of an ever-increasing renewable system in electricity. We also have contributions on new products with low carbon intensity. So I would like to call attention here to our program on biorefining, which involves biokerosene, it involves in hydrotreated vegetable oils, and those are plants that are already at commercial scale, although there are pending regulations for the full deployment of the projects. Those are already at industrial scale in our strategy, and those are all products with lower carbon intensity that meet with also our fourth topic, which is the R&D to low carbon solutions. So 10%, at least 10% of our R&D budget is dedicated to low carbon solutions. So here we have a very wide range of technologies being researched, from CCUS going through new production arrangements and modern renewables, so that we have an array of options to choose when we do our strategy, a number of options that we are capable of dealing with from the technology standpoint, so that we can choose and understand what has a fit for the company. So our R&D is much wider in terms of options than our industrial commercial portfolio. And finally, I think it's important to mention that we have also a decade of social environmental products and projects in natural climate solutions, which are completely voluntary. So all of the numbers we're going to present throughout this presentation are intrinsic numbers. So when we're talking about any reductions in emissions, we are always talking of reductions in emissions that are intrinsic. We are not talking about any offsets. However, that does not mean we don't operate on natural climate solutions. We have extensive support to projects. The indirect area of the project that Petrobras supports now is over 25 million hectares. That's more than 3% of the area of the whole of Brazil. So those are very interesting projects that not only have benefits for carbon, but they also have benefits for biodiversity, for water, and for the livelihoods and economic development of local communities that depend on the forest. We have 3 pillars on our carbon management. The first pillar is transparency. And we understand it is on the interest of society, it is on the interest of investors, and it is on the interest of us as a company that carbon is quantified and included in every critical process in a very, very transparent way. So when we see the magnitude and the challenge of energy transition in the world, and when we see the very important role that oil and gas have today in the energy matrix, it is absolutely important that we can communicate and that all of our stakeholders can understand how do we incorporate those challenges and those opportunities into our decisions. That's why we have a document called Climate Change Supplement that has just been updated, and it explains everything. How is our strategy? How do we manage climate risk? How is our governance, our remuneration policies, information on our data, etc. So that's the first pillar of our carbon management. The second pillar, and that is obviously very important because we are a company with a very strong investment in the exploration and production of oil and gas. So the second pillar is the resilience of that fossil position. So as I said in the beginning, our scenarios, and we do scenario-based planning for a long time, our scenarios show a clear change, a clear transition in place. It's not an immediate transition because it depends on the consumer base transitioning. Right now, all of the transportation base relies on fossil fuels, and it takes time until you change all of that infrastructure. And on certain areas, it even takes technology. We don't have the readily available technology to transition, like aviation. So when we talk about this retraction of demand, we start asking ourselves, and every company asks themselves, are we planning for fossil resources that are needed under a Paris-aligned world? And the way we look at it is that for any level of demand, so we now have about 100 million barrels per day, aligned to Paris Agreement, you were going to have about half of that demand. So at any point of that curve, from here until 2050, we believe it is important to have resources that fit in that demand. And fitting in that demand involves two key attributes. The first one, it has to have low cost, because if you have a retracting market, and if you want to make sure that you're producing fossil fuels that are needed in a Paris-aligned world, you have to have them to be the most competitive player at placing. You have to be the actor that is able to produce at the lowest cost. Because if you're betting on oil that does not fit a Paris-aligned demand. And I'm going to show a little bit more about that. But in Petrobras, every single resource we develop has to be positive with a price of oil of $35 per barrel. $35 per barrel is the level of price expected in a very fast transitioning world, in a transitioning world as fast as the net zero study from the International Energy Agency. So what we are saying is, like, we're betting on resources that are needed in a transitioning world. The third pillar of then obviously it doesn't have to be only a low cost production, it has to be low carbon. And that low carbon really means reducing emissions at production, reducing scope 1 and 2 emissions from your own operations to net zero in the mid-range. So it means being able to have very low carbon oil production at very low cost over time, and that's what we think. It's oil production that is aligned to Paris, and we call it the double resilience concept. Now, the third pillar of our carbon management is strengthening the skills to create value in low carbon. So when we discuss the scenarios, we can see the changes in the oil markets, and we can see the changes in every other energy product. So heavy electrification coming, increases in the electricity demand over time, increases in markets for sustainable fuels, for biofuels, for hydrogen. So we can see all of those markets developing. And we do have competences for many of those markets. So we make sure that our third pillar is strengthening those skills so that we can create value and capture opportunities when they arise in the markets we operate. Now, moving a little bit forward on our current strategic plan, it's for the 5-year plan. This is the first plan that we have. Petrobras has undertook a very important turnaround, financial turnaround effort to reduce debt. And when we plan 2022, 2026, we have reached all of our targets for debt under control. We always have the focus on value creation and distribution, investing responsibly, focus on resilient assets, as I said. We have last year announced net zero ambition for operations, and we have announced a new governance for profitable diversification. So what does it mean? It means that now that we have the debt under control, we are opening our minds and our governance to understand other businesses related to the energy transition that can be profitable for us and that can be developed alongside oil and gas. We also have refining modernization and the quality of the product. So we are focusing on having extremely modern, energy efficient refineries with very high quality products. We are investing in open markets for oil products and natural gas. So we support open markets. And we have a new frontier, which is at the very north of Brazil, on the equatorial margin. As I said, we have a net zero ambition. This net zero ambition is for scope 1 and 2. It involves our operational emissions and also the projects in which we are partners but not operators, so the projects in which we have equity interests, and our deadline is compatible with the Paris Agreement. So most of our emissions happen within Brazil. Brazil currently has the target of net zero in 2050, so that's what we plan for according to the Paris Agreement. And that decision is aligned with the positioning of OGCI, which is the Oil and Gas Climate Initiative. It involves 12 of the oil and gas companies that make up for 30% of the oil and gas production in the world, specifically to catalyze and find ways of accelerating energy transition. So when we take this net zero ambition, we do that in full alignment with the OGCI position. This net zero ambition, it obviously is a longer term ambition, but it does not come without short and mid-term targets. So we have currently commitments that cover 100% of our operational emissions for 2025, 2030, and then the net zero ambition for the long run. And our targets, they cover absolute emissions. So we have a target for reducing 25% the absolute emissions by 2030, but they also cover efficiency. So it's reducing emissions by gaining a lot more efficiency in our operations. And these efficiency targets involve our most important segments, refining and exploration and production. They involve a specific target on methane, which we have for some years already, and we know methane has gained a lot of projection now, as it should, in COP26, but we already had the target for methane 3 years before. It's important to say that Petrobras has only 3 metrics that we consider top metrics, which involve, which affect the remuneration of every single employee in Petrobras, and manager and executive, all the way to the board of directors. And emission efficiency is one of those 3 targets. So right now, within Petrobras, every single employee, every single manager and executive has at least 5% of the variable remuneration linked to emission performance. And some of our executives may have more than 15% of their remuneration linked to the carbon metric. We have incorporated $2.8 billion of capital expenditure, of CapEx, of investment in this 5-year plan. That involves the decarbonization of operations, and we have created a specific corporate decarbonization fund, which has $248 million in that fund to accelerate solutions to reach net zero as soon as possible. So this specific decarbonization fund, it's going to aim at looking at our marginal cost, at all of the hundreds of opportunities that we have to reduce emissions, and identifying the ones that are more mature and attractive, and it uses a carbon price to stimulate the incorporation of those technologies into our portfolio. So we have decarbonization of operations at the heart of our investment. And as I have already said, we also have $600 million in bioproducts, advanced bioproducts, so bioproducts with a very high quality and low emission profile, like renewable diesel and biojet. And as I already said, we have $130 million in R&D for modern renewable and for supporting this governance that we have into finding new businesses associated with the transition. So transition, it must be fast and just. And that always means decarbonizing at the lowest cost for society, because if you start doing what is more expensive before what is less expensive, you place unnecessary burdens on the ones that have the least access to energy. So affordable energy continues to be an extreme challenge that comes along with the challenge of low carbon transition, of the challenge of net zero. So we always have to be in mind that when we decarbonize at the lowest cost, this is not about benefiting companies. This is about benefiting society. Because if you're decarbonizing at the most expensive route, that is going to be somehow translated to the cost of society. And that's ever a more important burden to developing countries. It's when we say that transition must be fast and just, it involves differentiating goods and services by their carbon profile. We have to differentiate, and when we say differentiation, we say it for every product, including oil. So we have now oil fields that produce at 5 or 10 more times more emissions per barrel that is delivered to the consumer than other fields. So those we cannot consider that the same product, because if we think that the oil and gas industry has 4 billion tons of CO2 equivalent into the atmosphere, that's nearly 9% of the emissions of the world associated with the industry. So if you're talking about 4 billion, that is half of the emissions of all the transportation of the world. So we can see how much of an impact we have if we immediately start consuming products that are produced, or oil and gas that are produced with a lower carbon profile. It is relevant, it's not irrelevant. So it is very important, and that's why we're so transparent about the carbon intensity of our products, because we think it has a clear role, in particular in the short run, because transforming transportation necessarily takes time. You have trillions of infrastructure to be replaced, including the vehicles themselves. So if transforming infrastructure takes such a long time, it is very important that we take the good low-hanging fruit and choose the products that are produced with lower carbon. And when we plan transition, it's always very important also to build post-transition competitiveness and look into the co-benefits. So when you look at different routes of decarbonizing, if you look at efficiency, for instance, and you're saying, like, I'm going to improve the efficiency of the transportation of a certain country, I'm going to reorganize the infrastructure so that it requires less energy. That has a lasting impact, a very lasting impact on the cost of energy, on the cost of production, on the cost of transportation for a specific country. Now, if you decide another route that has the exact same amount of decarbonization, but instead of reducing the amount of energy that you're consuming, and therefore reducing also the emissions associated with energy, you choose something that you use the same energy, but now you use an energy that is more decarbonized, but it costs more, then you are increasing the cost of energy in a society. On average, the cost of energy takes about 10% of the GNP of a country. So it is something very relevant if you change the cost of energy. And that's why it's so important to understand for these different routes. And we do this assessment when we are analyzing the opportunities for differentiation for Petrobras. So that's why it's so important that we understand the cost of decarbonization and the cost of energy after you use that option. So as I said already, oil demand will retract over decades, but even in the most accelerated Paris-aligned scenario, you will have decades of oil consumption. We are dealing with sustainable development scenario from the international agency, something like halving the amount of oil in 2050. And if you look at the net zero scenario, which is extremely aggressive, you are also looking at 25 or 30 million barrels of oil per day in 30 years from now. That's why I repeat, it is important to plan on how we're gonna transition the primary sources of energy, but it's also important to make sure that we have oil produced more efficiently with less carbon emissions. It has an immediate impact on greenhouse emissions at gigaton scale. And this cumulative value of early results is also very interesting, because if we can reduce just 1 million ton of CO2 now, over the next 30 years, we're talking about 30 million tons, because you have the cumulative effect of that 1 million. So that's why early action is so important. Okay, so let's give a little bit of the numbers now. We generally have our numbers based on 2015 as a date of reference. That's because it's also the Paris Agreement signing date. We have reduced the emissions from 78 million tons of CO2 to 61.8 last year. So a strong reduction in emissions. If we take thermal electricity out, because in 2021 we had a record amount of electricity, of thermal generation, because of a very dramatic lack of water in the hydroelectric reservoirs. So if we take thermal power production, we can see that our core oil and gas has also reduced emissions from 56.5 to 46.5. So again, a strong reduction in emissions in oil and gas core operations despite increased output. And it's when we see the core oil and gas, you can see a constant decrease of the absolute emissions. And absolute emissions are the bottom line of everything. That decrease comes because we have improved efficiency on almost every aspect. So you are now seeing the graph of our direct methane emissions, and we can see that we halved the emissions of methane over since 2015. We nearly halved the methane emissions. Those are real reductions because you are discussing things like having less flaring, for instance. So you measure how much gas goes to the flare. And you look at when you look at the efficiency in methane emissions, it is 3 times lower. So we are now operating at 0.33 tons of methane per 1,000 hydrocarbon produced. So you can see a very large gain in emissions, in very large reduction in methane emissions, which is in line with our concept that methane emissions have to be near zero. You can see that the efficiency in the exploration and production has also halved, not the efficiency halved, the emissions per barrel halved, because you are 2 times more efficient. So if in 2009 we used to emit 30 kilos of CO2 for each barrel produced, we have finished 2021 at 15.7, and our large fields in the pre-salt, such as Búzios and Tupi, they are operating under 10 kilos of CO2 per barrel produced, which is solidly, those are solidly fields among the most decarbonized production in the world. So this has a number of technologies that support. The pre-salt fields are extremely productive, and that is good, but you have very solid choices in having very high gas utilization. We have fields that now operate over 99% of gas utilization. The average of the portfolio was 97.2 in 2021. And we have an accumulated amount of CCUS of 30 million. In 2020, it was the largest amount of reinjection in the world. So it was the largest operated project of CCUS in the world in terms of the volume stored in a single year on the Petrobras fields on the southeast of Brazil. So when we look at all of those numbers, we like to say that there is a value of having lower carbon oil and gas production. And the value of that is that it's a lower cost than other fuel alternatives. It is a source of revenue because oil is a heavily taxed product. So when you have a country that produces oil, they also have a source of revenue that can help finance the transition of the infrastructure that is necessary for in the long run replacing this product. You also have gas for the stability of the electrical system that I already mentioned, and all of that shows that the oil has a transitional role. When we look at all of the opportunities for decarbonization, we can see that some of the niches of energy services that are the most expensive to decarbonize are exactly the ones that are related to oil. And that's why you don't just swap oil away. It takes massive cost and change of infrastructure to replace oil. So you have to do everything else that is cheaper from a societal standpoint, so that you can reach the maximum possible and the quickest possible decarbonization with the same cost. Now, as I said, we had 30 kilos per barrel in 2009. Then we were 20 in 2015, and we come improving and improving and improving until we reach 15.9 and 15.7. But we still aim at continuing to improve our efficiency. And our short-term target is 15 by 2025. So as Fabricio is here with me on this table, and he's ahead of the engineering for this field, I'm gonna send you a question, Fabricio. How are we gonna do that? How are we gonna continue? We are reaching now levels of, like, the low-hanging fruit has gone, right? So how are we gonna continue moving downwards our intensity curve?
Okay, thank you, Viviana. So let me try to reply that. Before showing the challenges that we have and next steps in the future, I just would like to have a step back and look back 10 and 20 years ago, how the design of our FPSOs were and the main features, to see the trends on that. So when we look at the processing capacity related to oil production, we see that not change a lot from 180,000 barrels per day to 180 to 125 barrels per day. But when we look to the gas processing, we have doubled that from 6 million normal cubic meters per day to 12. And it's not only the gas flow, which brings complexity to the design and to the engineering and to bring solutions to emissions. We also have the pressure of this gas. So we had previously up to 200 bar, which is the exportation gas pressure. And now we have up to 550 bar. So that increases a lot of the complexity of the units. And we foresee in the future more than that. And this, all of this brings weight to the unit. More than half of the top sites is to deal with gas treatment and compression. So we can see that the weight of the units were about 50 to 75, the whole FPSO, and now we have units ranging from 120 and 140,000 tons. And the complexity of these units brings more energy demand. So we had about up to 75 megawatts. From recent fields, we had up to 100 megawatts, complemented by about to 25 megawatts for turbo compression. And now we have, we foresee more than 150 megawatts. And all of this, which represents the energy demand to generate power to the FPSOs, it's the main contributor to greenhouse gases emissions. So we had before up to 30 kilos of CO2 equivalent per barrel of oil equivalent, and now we're talking about less than that, less than 15. And this brings some additional challenges to the engineering design. So in the next slide, we can try to summarize. If please, sorry. Before that, so linking to the portfolio that we have now, looking to the near future, here we can see this our strategic plan 22-26. If we take a look of the what is foreseen in market reports, we have within this period 22-26 in the whole world about 25 to 26 FPSOs to be installed and to start production. And Petrobras has more than half of that in its portfolio. So you can see here in green filled in green, pre-salt units under construction, and in yellow you can see post-salt units under construction. So of them up to 2025, and in 2026 we have 3 units to start production on 2026. So we have right now under procurement these 3 units, the green ones for pre-salt and the yellow one for post-salt. In next slide, we can summarize this challenge to design these units. So in the previous slide, we see what is already in our strategic plan, but as engineering, we have to design the units that will be installed after that. So we are doing this right now. So we are working on the next generations of the FPSOs, and we can summarize the challenges in these 6 points. We have some contaminants like CO2 and H2S within the petroleum, and this brings complexity because we need to have more systems on board. We need to have more modules on board. We need to have materials that are have more stringent requirements to be applied within this unit. We also have higher gas to oil ratios. So if you look at Búzios field, we have a little more than 200. In Libra, we have a little more than 400, and we foresee that we can have more than that. Also, higher reservoir pressures, and all of these brings complexity and requirements to the gas treatment, gas processing, compression, and reinjection capacity, which in consequence requires more energy. And with all of that, we have higher, bigger FPSOs in size, in density, in weight, and also in capacity. So in the next slide, we can see what we have right now. What is our standard design? What we have adopted up to now as a reference. So you can see in the bottom right, the solutions that we already apply as a standard for power generation, which represents in a typical FPSO about 70% of greenhouse gas emissions. So we already have installed cogeneration by means of a waste heat recovery unit. We treat the gas, the fuel gas, with less than 3% content of CO2. And we also apply variable speed drives into the compression system. If we look at the top part related to vents and fugitive emissions, we already made use, as Viviana already showed the numbers, of CCUS. We also increase the oil treatment temperature and decrease the oil treatment, the oil storage temperature, so we can reduce the amount of vented gas. We included also into the design process ventilated gas recovery system from P78 on, and also low fugitive emissions valves from P80 on. And in the left part of the slide, we can see related to flaring, that represents 20% of our emissions in FPSOs. We have already as a standard flare gas recovery system. And when you need to burn, we specify high efficiency burners. In the situations that we have to burn, we use this kind of burners. Also, we consider pressurized stop of compression systems, nitrogen as assistance, and cooling gas in flares, and sequence depressurization of the inventory. So this is what we have as a baseline right now. And for the future, you can see in this slide, the yellow bars are to scale, the gray bars are not to scale. So the reference, which considers all the solutions that we showed in the previous slide, we have already achieved zero routine flare for the design of these units. And we are working on an all-electric concept for the FPSOs. So what does this all-electric contains? What is packaged within that? We have electrified all the top sides, There was a recent change in Brazilian regulation, which is CONAMA, that now allow us to have an unit that is more than 100 megawatts. If the top side is fully electrified, we can adopt that solution, so we can centralize all the power generation and do not have more turbo compression, and this brings more efficiency to power generation and also to emissions. We are applying into these new designs that we are preparing now. Deep seawater intake, more than 100 meters. Seawater cooling system, we did an optimization in the system and did the same for gas treatment and compression systems. And we are also assessing and evaluating cargo tanks, hydrocarbon blanketing and recovery system. So with all of that, we have a potential to reduce even more, up to 30% more than the reference that we have now. And next steps, they require a little bit more challenge. So the next steps, we have a potential to reduce up to 10%, which would be additional energy efficiency actions and combined cycle. We are evaluating that. There are some challenges related to the features of pre-salt fields, which demand not only high power, but also high heat input. And we must find solutions to develop a system that can keep efficiency, operational efficiency, and reducing also emissions. So there is an economical challenge in that, and there is also some engineering challenge. And the last portion of that to achieve net zero would be CCUS on exhaust gases from the gas turbo generators, and also alternatives related to electrical power import, either be it partial, the CCUS, or power import, or either be integral, and more additional energy efficiency actions. So this is what is in our view, what we have to overcome, what we are doing right now, and what we foresee for the future. Okay, so Viviana, thank you for the opportunity of sharing these slides. So please, with you again. What else do we have?
Thank you, Fabricio. So as Fabricio was showing, innovation has been key on this journey up to now and will continue to be key. Because when we look at the right side of the yellow bars that he's showing, he's looking at economic and technological challenges. And when you see economic challenges, they are also technological challenges, because you have to bring them into economic conditions or reasonable conditions to be implemented. So when we have already incorporated a lot of innovation, reinjection, flare gas recovery systems, fully electrified platforms, digital transformation, we are now planning on things like maximizing submarine separations, something like a high pressure separation unit in the bottom of the sea can also reduce intensity. But when we look at the net zero challenge, we are looking at a lot of innovation being incorporated. And that innovation comes into new standards for new fields that we're going to develop. And it also comes in the form of how are we going to decarbonize existing assets? And Petrobras has a long history of incorporating innovation into its operations. And that history comes from a culture of making available the technology that we need. We do not drill over salt in such deep waters because the technology was there waiting for us. We actively look for technology, and that search is now in place also on how are we going to decarbonize in our own specific conditions. Because if you have operations like pre-salt, they have a lot of advantages for decarbonization. They are very high productivity fields. We have clusters of actions, but at the same time, they are in very deep water. They are away from the coast. So it all requires a specific set of skills. So we have launched beginning of the year what we call the carbon neutral program. And the carbon neutral program, it aims at making sure that we have the technology at the cost that is acceptable when we need it. So we have one area of it is what we call operational excellence. Operational excellence really means eliminating losses of anything, losses of methane, losses of energy, losses of gas through flaring. So we're talking about operational excellency for the assets that we already have. Then we have a field which we call disruption. Disruption is about learning how to do new design that is already born net zero. And it's also about finding integrated disruptive projects that can decarbonize the assets that we already have. We have one group working on the decarbonization of supply chain, one group working on solutions for scope 3 emissions, and one group working for removal of CO2, which involves both natural climate solutions, but also engineered removal solutions such as CCUS. This program is supported by a decarbonization fund, and this decarbonization fund has is an incentive for the development of solutions. It's a program to speed up solutions, and it uses a carbon price to stimulate the deployment of solutions that are almost economical, but not yet economical. And as I said, for any company or any country or the world, you always want to do what is cheaper before what's expensive. That's why we use a marginal abatement cost, as we use a portfolio approach for carbon. When is the next ton of CO2 that I can eliminate at the lowest possible cost? We can see that we still have on the very left end of our curve, we still have some opportunities that are actually NPV positive, efficiency opportunities. And then we have over 200 mitigation options planned and quantified at different levels of maturity. And I like to say that the carbon neutral program is about finding the technology and finding the way of doing those things on the right side, cheaper, and having them available for our company. So that's what we are about in the short term. We have very little time to learn how to deploy all of that so that we can be as low as possible in 2030 and net zero in 2050. And that was my last slide. Thank you.
So thank you, Viviana, for the great presentation. We have a few questions, time for a few questions from the audience. I'd like to stimulate everybody to put your comments or questions in the chat box. I'll start with one from Oscar Chamberlain. He says, in the last IPCC report, James Kew mentioned that it's now or never if we want to limit global warming to 1.5 Celsius degree without immediate and deep emissions reductions across all sectors, it will be impossible. Considering that, what Brazil and Petrobras will need to do until 2025?
Okay, so I'm going to start by answering on the Petrobras side. Petrobras needs to fully deploy until 2025 everything that the technology is available. So everything that we have technology to do at reasonable cost has to be deployed. And that's why we created the Decarbonization Fund. That mostly involves operational excellency. It involves like going to the extreme in energy efficiency and in reducing losses. Now, until 2025, we also need to learn how we're going to go to net zero in nearly 2 decades, which is not that much time. If you think that a field, for instance, it starts being designed and decided 6 years before it goes into production, and then it works for 2.5 decades. You are really designing things now that are going to be operating in 2055. So we have a very short window to make the technology available that is going to allow us to do the deep decarbonization that is required in the oil production for the mid for mid-century, aligned to Paris. Now, when we talk about Brazil, I would say that for any company or any country, you have to look for the lowest cost opportunity. Brazil has an extremely particular profile of emissions. It's absolutely unique in the world because our energy is already very decarbonized. I don't know if everyone in the audience is aware, Brazil has the most renewable matrix in the whole of the G20 by far. The only country that is about the same level of decarbonization of energy is France, because of its nuclear base, not because of renewables. So we are such a decarbonized country in terms of energy that the whole of the energy emissions are less than 1/3 of the emission profile of the country. So the whole of the structure of the decarbonizing Brazil has different costs of opportunity than most of the world, and therefore requires the same economic approach into doing what has the least burden to society, which has the least cost. Usually it is things that require efficiency. So Brazil has to look for efficiency in its energy use. We use 3 times more fuel per unit of GNP of revenue of the country, because our infrastructure can be improved. So we have to look at efficiency, and we have to look at things like land use change that they still have opportunities at very low cost.
Okay, Viviana, thank you. There's another question here from Eduardo. Does Petrobras use a carbon price in the assessment and prioritization of its projects?
We use carbon price since 2019 as sensitivity assessment for investment. So all the investment has sensitivity assessment of its NPV depending on different carbon price levels. We have carbon price fully incorporated as an internal carbon price that comes in as a revenue stream for the Decarbonization Fund. So when we test the investment of the company, the carbon price is sensitivity assessment, but for the Decarbonization Fund, the carbon price is actually an internal carbon price fully incorporated into the stream of revenue, so that CapEx can achieve projects, that it's an incentive through this carbon price to do decarbonization options that would not go through if we didn't have the carbon price. That is only for the Decarbonization Fund.
Thank you, Viviana. I think we have maybe time for just one more. There is one question here that maybe I can help to reply. It's from Jude. The question is, I would like to know why you would require a combined cycle power plant on board an FPSO, and how feasible it can be to install it, considering the rather large footprint. So let me try this one. The reason why is because we can have up to 10% reductions in greenhouse gas emissions, and in fact, it is quite a challenge to, as the units become more complex, to put it inside the arrangement that we have. So to do that, we must make use of the recent change in regulation. So we can use larger turbo generators, and there was less quantity of that, so we can improve the arrangement to allow space for the combined cycle. But there is a challenge that is to how we can achieve efficiency when we need a high heat input demand to the processing facilities, and having stability about that. So that's one point that is the engineering challenge to have solutions for that. Well, I think we have already achieved the end of the presentation. I would like here to thank you, Viviane, again, for preparing the presentation, for sharing your time with us here. I'd also like to thank OTC to enable this live. I hope that the audience has enjoyed as well. So I'd like to thank you all, and be safe and be healthy. Thank you.
Innovation is in our DNA. This is how we expand the limits of knowledge and our technological frontiers for discovering, developing, and producing in various giant oil fields in ultra-deep water, in a complex production operation, confirming our technical capacity and global leadership, all with maximum production efficiency and lower carbon emissions. This is energy for transformation.